Okay, good afternoon, dear friends and members of IMGA. It's a pleasure for me as chair of the executive committee to say hello to all of you and to say thank you to Mariano Cáceres for this opportunity. He's going to talk about geoenvironmental risk study due to the arsenic presence in the main aquifers of southwest Uruguay and its possible impact on human health from a geomedical approach. He is the winner of one of the awards of our main conference, MedGeo 2021, that was virtual due to the pandemic. And the award is the possibility of give this presentation to all of us. Also, he is going to receive a certificate and also 100 euros as a prize for all the effort that he is doing for IMGA. And I want to say thank you also to Nelly Manae, that is the advisor for his thesis, his master degree presentation. Also to Chao Shen Zhang, that is vice chair of the Association for the Medical Sciences, and Elena Alvareda, that is our secretary. And a very, very important mention to Maria Aurora Armienta, that is the leader of this webinar series that today for her was impossible to be with us, but thank you, Maria Aurora. I don't know, Nelly, if you want to say something else before Mariano?
No, only to say hello to everybody and thank you for being here. And I'm very proud to be to be in the presentation of my student that has already finished his thesis, and he is going to defend it in the following weeks or perhaps in 2022 because of but he has already accomplished his research, and I think it is very original from the geological science or geosciences to show how students of geoscience can manage with medical geology research. Okay, thank you, Diego, and thank you, everybody.
Thank you very much. Well, Mariano, it's all yours.
Okay, hello and welcome, everybody. This research work is titled Geoenvironmental Risk Study due to the arsenic presence in the main aquifers of the southwest of Uruguay and its possible impact on human health from a geomedical approach. And it was developed in my master's degree in geoscience at the University of the Republic in Uruguay, under the supervision of Professor Dr. Nelly Manae. As a starting point, I will show you an introduction with a few definitions, the objectives, the methodology used, the result obtained, and the discussion and conclusion about it. Okay, medical geology is an emergent or emergent discipline with a multidisciplinary approach. It studied the impact of geological materials and their processes in public health. It has had several names throughout history, such as geomedicine, geographical medicine, and the term medical geology was accepted in 1997. It has three main pillars. They are medicine, with study of exposure and the effects on human health. Geology, from petrology, mineralogy, and hydrogeology. And geography, from spatial analysis and distribution studies. Okay, arsenic. Arsenic is a 33 atomic weight metalloid. It's toxic, and it's in organic species 3 and 5, human carcinogen category 1, declared by the World Health Organization. It can be present in groundwater in values that exceed the limit established for human health. In Uruguay, that limit is 20 micrograms per liter, while the value suggested by the World Health Organization is 10 micrograms per liter. In Uruguay, this was the goal for this year, but it was postponed to 2023. Arsenic is present in many types of rocks and minerals. There are a few main minerals where arsenic is concentrated or its presence is abundant or abundant. The main minerals that constitute an ore mineral of this metalloid are arsenopyrite, oropiment, and realgar. And others with important amount of arsenic are pyrite, sphalerite, chalcopyrite, iron oxides and hydroxides, and others. Well, the arsenic can be present due to many natural or man-made causes. Some anthropic source could be the use of arsenic-based chemicals such as insecticides, animal disinfectants, and herbicides. Also, wood treatment with CCA process, or the electronic industry with the use of gallium arsenide and other industries, of course. The geogenic contamination can occur throughout the processes of reductive dissolution and desorption, desorption under oxidizing and alkaline conditions, or by dissolution in oxidizing and acidic conditions. All these processes occurs in minerals and rocks in the geosphere and hydrosphere, allowing their geoavailability. Well, among the main adverse effects due to chronic consumptions are cardiovascular problems, various types of cancers such as skin, melanoma and non-melanoma, lung, bladder, kidneys, liver, etc. And chronic endemic regional hydroarsenicisms, o ACRE in Spanish, como hidroarsenicismo crónico regional endémico. Well, the local context. The study area consists in approximately 55,000 square kilometers in the southwest region in the country, here in the shadow area. The study includes 89 towns with more than 200,000 inhabitants. But the capital of each department is the subdivision in the country. The capital of each department was excluded because their water supply comes from rivers. Okay, and the geology of the area is mainly crystalline basement as a central stripe with a Paleoproterozoic age. It's made up of 3 volcanic sedimentary belts interspersed with tectonic scale composed of granite of anatexis and migmatites, and Paleozoic basins, mainly of Cretaceous age. There are 2 in the hydrogeology. There are 2 main types of aquifers: the sedimentary aquifers and the fracture aquifers. The sedimentary aquifers are developed in sedimentary basins such as Salto, Mercedes, Raygon, and the Cretacic sediments of Cretacic soil in the Santa Lucia basins. And the sediment Cretacic function as aquifers in this case, while the fracture aquifers are developed in crystalline basement. Okay, the local contact for cancer in Uruguay. The data was collected from the report epidemiological situation of Uruguay in relation to cancer in the period 2011 to 2015. The cancer deaths constitute approximately a quarter of the total deaths registered in Uruguay each year. In the period 2011-2015, registered in the National Cancer Registry, more than 80,000 incident cases of malignant tumor are shown. With the exception of non-melanoma skin cancer, the 4 most frequent types of cancer in Uruguay are the same as those observed in developed countries: breast in female, prostate, colon rectal, and lung cancers. Well, the objectives of the general objectives in this thesis are evaluate the arsenic levels of natural origin in groundwater destined from human consumption in the southwest of the country, develop and prepare environmental risk maps for human health in this region, address geoenvironmental and human health problem with multidisciplinary and versatile tools according to the new trends in geoscience. And the specifics objectives are generate a database on the presence of arsenic, of environmental arsenics in groundwater of the study area, look for possible relations between exposure to environmental arsenic with the incidence of cancer type associated with it, and offer an accessible and practical tool for future risk studies due to environmental factors. Okay. Well, the methodology. The methodology consists of obtaining data from official source, such as OCE, is the official supplier of potable water, and MEVIR for geochemical data from water wells. The Honorary Commission to Fight Cancer, o Comisión Honoraria de Lucha contra el Cáncer, for cancer data, and the National Institute of Statistics for social data. Then we proceed to process and depurate them to later use them in the elaboration of risk maps, statistical calculations, and graphics of temporal evolution on arsenic. Okay, the results. Well, with the data obtained, we create a database from which we generate density maps or heat maps using the values of arsenic in groundwater and the cases of cancer incidence. In addition, statistical parameters were calculated, such as correlations, regressions, and propensity score matching. And the temporal evolution of arsenics in wells was also represented in graphics plotted with several measurements. Well, in the left side, you can see the location of the wells and the arsenic levels on a dotted map. In the right side, a heat map or density map with the arsenic value of each well. There, you can visualize the areas with higher levels in the department of Canelones here, Colonia here, and Rio Negro here. Okay. The map, the left map, shows the incidence of non-melanoma skin cancer in women versus arsenic levels in groundwater. The cancer is with dot point. It's represented in a heat map of arsenic level with a cancer dot map overlay. And the right map, it's just a dot map of town with cancer incidence. This was made for each type of cancer, divided between female and female. Each type cancers are lung, skin melanoma, and skin non-melanoma, bladder, kidney, and the other. Well, 9 points. Liver, this is there. Sex. Okay. The temporal evolution of all well maps of all wells, considered shows downward trend in arsenic values in this case, but separated by location arsenic behavior is not longer shows a clear trend. Individually, wells show variable behavior. In some cases, like this, in here, there are fluctuating values and ascending patterns here, descending patterns here, and stable patterns here. Okay, the arsenic parameters. In the violin plot, in the right side, we can observe the distributions of arsenic values within each study aquifer. Raigon here shows a behavior of stratified values, while in the box plot here, it's observed that the medians are below to the limit values for Uruguay, with some atypical values in all of aquifers. The cancer parameters, the incidence for each type of cancer is separated in male and female in the period 2011 to 2015, shows a major incidence in lung cancer in male here, and skin cancer, no melanoma in male and female in this region. Okay. The correlations. Okay. In the correlation of in the calculation of the Pearson correlation coefficient with the physical, chemical, and geochemical variables, we can observe statistically significant positive correlations only with pH, total alkalinity, and fluorine. But for the Pearson correlation coefficient between arsenic and cancer types, show that no correlation was found using the current data. Okay. In the regressions and propensity score matching for the comparison between the models, and doesn't give a statistically significant association between arsenic and cancer for all models. And in the propensity, there were no good covariate for good performance. The control group size, so towns without arsenic, is much smaller than treatment group size, the towns with arsenic. Also, more studies are required to achieve a better fit by propensity score matching. Well, discussion and conclusion. Mapping the spatial distribution of arsenic and any other geochemical element is very important as a first approach to analyze the problem. This observed in multiple research, such as Morales-Sinfor in 2020, where a critical review of the geochemistry of arsenic from geothermal resource and volcanic emissions in Latin America is carried out, pointing out the need to develop of GSMAP to understand the nature of the problem. Also, the research of Baumig in 2015 with the elaboration of risk map for human health due to exposure to trace metal contaminations in water source for human consumption in Pakistan. In the epidemiological mapping, Chile has a bladder cancer map separated by communes based on the characteristic of each place. In Uruguay, is only for department is the major separation in the country. Therefore, a complete and constantly updated database is needed according to the geochemistry of the different environments, soils, water, air, etc., as well as the local flora and fauna that may show a sign of possible affectations or sign of anomalies that can lead to a risk for human health. Well, the temporal variation of arsenic found in this study, as well as its variability in spatial distribution, agrees with other studies carried out in other parts of the world. The research of Armando Cruz, 2020, in the city of Durango, Mexico, show that the local variation of arsenic and fluorine at a spatial and temporal level will be influenced by alluvial deposits and acidic basement rocks, such as rhyolites and tuff, as well as local factors such as extractions, precipitation, and evaporation. Also in Claromeco in Argentina, Sierra 2008, they studied the variability of arsenic and fluorine, integrating hydrogeological studies with hydrochemical and geophysical techniques, allowing the identification of lateral and vertical variation, the values of arsenic and fluorine, as well as the influence of alkalinity on the total content of arsenic and fluorine. It serves to visualize spatial behavior of arsenic and allow us to suppose that its distribution varies with the time. Also another research by Jules Castro Marino in 2005 in La Pampa highlights the determining factors of the generally erratic behavior of arsenic, such as space with the climatic, geological, and geomorphological factors, and time. Okay. Regarding the correlations, the correlation of arsenic with pH and fluorine is in accordance with the research of Machado, Buell, and Mañay in 2019, where they find a strong positive correlation between total arsenic with fluorine and pH, also of arsenic 5 with sulfides, but no with total arsenic with sulfides, as occurs in this research where the correlation with sulfides is not significant. We didn't obtain any significant correlation in the cancer data, despite having worldwide antecedents such as case and control studies in Chile on the causality of arsenic in lung cancer by Ferrecho, to mention some of them in the world. On the other hand, there are studies that doesn't show a correlation between arsenic and cancer, such as Bedewi 2021, considering arsenic in urine and water source. They didn't find a significant association between the incidence of melanoma and non-melanoma skin cancer and urinary arsenic levels. However, no municipal water source were associated with non-melanoma skin cancer. Bastrup in 2008 in Denmark didn't find a significant relation with lung cancer, bladder, liver, kidney, prostate, colorectal cancer, or melanoma skin cancer type, except non-melanoma skin cancer, in which high arsenic concentrations were associated with low-risk cancer. Well, conclusions. The integration of schist tools together with geochemical and epidemiological studies is essential for understanding the behavior of the different elements and disease studies in terms of their behavior in a spatial distribution, but of given what's at a given moment or in its evolution in time. Other confounders should be considered when evaluating correlations and regression of arsenic with other variables. According to this study, where the current data didn't show a significant association within cancer types and arsenic levels, the influence of other chemical, social, and health factors cannot be ruled out, which may be masking another results. It's necessary to implement a geochemical database of the national territory to centralize water, soil, and atmospheric data, allowing data to be crossed and used in multidisciplinary research. Likewise, an open epidemiological database should be designed which preserve the identity of individuals, but allows the referencing of any pathology together with information of nutritionals and labor habits, etc., for enriching their results. More studies are required to provide information about arsenic and its relation with cancer and other pathologies in Uruguay, considering other variables that may not have been considered in this research. It's essential to deepen the knowledge on the behavior of arsenic in the different aquifers, looking for difference between them and exploring possible natural or anthropic causes that could be conditioning factors. Another aspect to consider is to deepen the study of the behavior of the aquifers and to carry out regular monitoring of the wells to continue collecting information that can provide new clues to their geochemical spatial variability and to be able to search for new relations between no previously considered variables. Okay, it can be shown that throughout the development of these tools, it's possible to overlap geochemical and epidemiological data, providing a scientific basis for the study of health risk. Thank you a lot. Thank you for your attention. Finished?
Yeah. Thank you very much. I think Elena is going to coordinate the discussion.
Yes. Hello, everybody. Thank you for all of you to be here joining the Mariano Cáceres webinar. Congratulations, Mariano. It was a very nice speech and a very interesting work. So, anybody has a question for Mariano, please?
Easy question, please.
Okay, I think I've done a very good job anyway. Congratulations on your award. I just have some questions about, first, your data, you have 89 locations, is that right?
Yeah, in this region, I consider 89 towns, small towns, because the cities of or more the ground cities, such as the capitals, the supplies, the water supplies is from rivers. Also, the small localities, the 89 localities, the supply of 89 localities, it was underground water supplies.
So the 89 locations, are they points or towns, or what are those 89 sites?
Are
they're points,
small towns
or towns?
Yeah, small towns. The size of the town, the size of the towns.
Mariano, I understand the place where you took the samples. It's okay, Choshen, you are asking that?
Yeah, I want to know they are point samples or areas.
Ah, okay, okay.
You're talking about 9 towns or 89 wells or locations. I don't know.
Oh, okay, okay, okay. We consider an area of influence the location. Anytime any towns has 1 wells or 2 wells or 3 wells in the area, but the influence radio it was 5 kilometers around for the geochemical data. For the epidemiological data is the data of the Atlas of Cancer. Also, it's
it's not clear to me anyway, because that's related to your data, including the heat map and the points of cancer. So for the arsenic map, you produce the heat maps. In fact, we seldom produce heat maps for geochemical data. Normally, we use spatial interpolation. So that's I just wonder how you produce those maps because related to your locality. That's why.
Oh no, yeah, yes. In the heat map, many wells are locations in towns and others in the land in the rural area for the heat map.
Okay. Anyway, I think you have to really think about if you really should use a heat map or use spatial interpolation, because normally for geochemical mapping, we always use interpolation. For example, you use IDW, inverse distance weighted. That's the easiest one and also popularly used. If you use more advanced ones, will be kriging. So heat map is very rarely used anyway. So I think as a reviewer, definitely will ask you, well, why do you choose the heat map and does it really make sense? And then it seems as you put the, the cancer data also as the points. So that I don't know why and how you get the cancer data, because cancer data normally they are aerial data. That's a statistical data, I don't know how you put them as the points again.
Yeah, in the Atlas of Cancer, the data for cancer is represented in maps, but it's painted the total department. Also, for georeferencing the data of cancer, I simplified the data for each locality, for each town. We have a list of towns with the total cancer for each town, and it plot these data in the map.
So the arsenic data are also based on towns, and cancer data are also based on towns, and the 89 localities are towns, not points. Am I right?
Yeah. The cancer is the cancer data. It's in towns. It's a town, but the
arsenic.
The arsenic data it's in wells, but
so you use one well to represent a town.
Yeah, I don't include the total wells, but we have 209 wells for the data arsenic.
So you have 209 wells.
209 wells for arsenic is the heat map.
Okay.
And the 89 towns is the data for cancer. This is very confusing, but the data is harmonized. The data is complicated here.
Okay.
Yeah.
Anyway, that's fine. I think you have to really make it very clear to the readers.
Yeah. This is...
Another question, you use the Pearson correlation. In fact, I have to let you know, Pearson correlation is almost banned in geochemistry. You are not allowed to use Pearson correlation. Perhaps if you ask Alex from Greece, definitely he won't allow you to use that method. And what we use mainly, we use the Spearman, use non-parametric methods because of the normality issue. Because in fact, it didn't really tell us the normality of your data. And in geochemistry, data is almost impossible, very rare for them to pass the test for normality. So if you use the correlation analysis, really think about the non-parametric method anyway. That's just a change, just an idea for you to consider.
Can you repeat me, please?
Yeah, and try to use non-parametric methods for correlation analysis instead of the parametric methods. That's my suggestion to you.
Yes.
Try to use non-parametric methods. Yeah.
Yes, I use the Pearson correlation because the number of data for locality with arsenic and cancer for the correlation calculation. We have less we have 28 data for the correlation. For the correlation, we have 28 data.
Okay.
The suggestion we received it was use the Pearson correlation, but
anyway,
yeah.
just my suggestion. If you want
for the number for the small number of data.
Anyway, if you use a parametric method, you have to.
I calculate for Spearman.
Yeah.
In my desconocimiento, but the results was very similar. Yeah.
Yeah. Anyway, even similar, I think to be safe for you anyway. If you want to use a parametric method, you have to test normality. And to be safe, just use non-parametric method. In geochemistry, normally we just tend to abandon those parametric methods. Anyway, just keep that in mind. You may get, so if the
statistic for me, the statistic for me, in my case, is very my first time. It was a new word, and maybe I have errors, multiple errors, but
don't worry, you have done very well.
No, I think that if you have all the information, you can make again all the calculation as Geoenvironmental suggests. So there is no problem with that if you have the data. With the other problems that the data has. No?
Yeah. You can even do a comparison, just try to take those factors into consideration. Well done, anyway, well done. Thank you.
Okay, thank you so much.
Thank you.
Chao-sen, please, Mary, go ahead.
Of course, it's not a question to Mariano, but I wanted to stress that this was originally planned as trying to see if in Uruguay, we do not know anything about arsenic in groundwater. So we began to work on this with some geologists, and we worked by our own as toxicologists and with some physician that was involved. So we wanted to share, to know what was the data that were available in our country, because our country is has a very important cancer incidence, but we do not have any epidemiological study, any that has to do with environmental problems. So what can I say? This for the world perhaps is not so relevant a study in Uruguay, but it's the only, we weren't in the map, in the worldwide map. If you see, as some many years ago, we didn't the water, the groundwater was very high in Argentine and was very high in Brazil, and in Uruguay, nothing happens because we do not have any data. So those data that Mariano worked on from his background, that was a geologist, and he worked on statistics, he learned a lot, he learned from epidemiology, was to match what happens with our registry of cancer and our registry of arsenic data, that was the official one, because we have 95% of the drinking water is supplied by our official work, official source, official agency, that is OCE. And Paulina, for example, that is here, and she's always, she also will present her work, is working on those wells that are not official wells. I mean, that are private, that do nothing to do. She is measuring those private wells. But the wells that that Mariano worked were those that were officially measured and has high levels, that our official supplier has to ask for the Ministry of Health for permission or to allow them to supply that water with those levels without remediation. I think that Mariano, I don't know if he shows, but what happens with the locality, he has to work on those data to try to make something that that makes sense, and that has to do with the first work that correlate arsenic with cancer, among other things, but also highlights that our data on health and on environment and on water, everything is not harmonized at all. And it changes with the authorities, and he has a lot of different kinds of database to work on. So that's all, only to know what happens in Uruguay with this problem, that is not a problem for the health authorities. Now perhaps they can manage something about this. But all physicians that worked on the map, on the Atlas of Cancer, were concerned because they do not take the environmental data as a data in the register, or the registration or something like that. So it's only to point out that is also in the thesis, the lots of difficulties to carry on this kind of work in Uruguay with available data. And we do not have enough money or projects to carry a very long, how do you say, well, a study from the beginning. We presented many of these projects, and now they are concerned because Uruguay has the end point, or the deadline in 2021 to download the data from 20 to 10, and we are not we couldn't. So the water supplier asked for more time for it. And in Argentina, there are 10 years from their data. Argentina has, that is our neighbor, has 50 micrograms per liter as their arsenic level, allowed arsenic level for the people. Well, that's all, sorry.
Okay, thank you so much, Nelly. And Dr. Dimitrios, please go ahead. You have the mute, the microphone. Okay.
Yes. Can I speak now? Hello to everyone. This is my first participation webinar of IGA. I'm very happy to be here for accept us in a MGA. And dear Mariano, for your interesting presentation. Can you hear me or not?
You will have to download your video. It's very slow, your bandwidth. Perhaps you have to close the video. Sorry.
Ah,
okay.
Yes, I
it
can do.
says your bandwidth is wrong. Okay.
Okay.
You look young.
Okay. Okay. Hello to everyone again. And I'm very happy to be here cooperating with you. I'm a new member of the IMGA, and thank you for accepting me as a member. Dear Mariano, congratulations for your interesting presentation. I would like to ask you if you have any data about the geochemical composition of the rocks and sediments outcropping the broader area.
Now, the study of, in this case, in this research, I don't study the geochemical composition of soil or rocks. This is for future research, but in this case, only I am focused in the data from in groundwater and cancer data and social data.
Okay, and I'm sorry for not attending your presentation from the beginning because I have just finished my lecture in the university. Can you inform me about the range of arsenic content in groundwater?
Yes, the medians of values in each aquifer is below to 20 micrograms per liter, but we have a maximum value of 104 micrograms per liter. And we have 4 wells with more than 50 micrograms per liter, and the maximum value was 104 micrograms.
Okay.
Values very low in comparison for the region. For example, in Argentina, the values are very high.
It is very interesting to identify if there is a geological or anthropogenic source of the arsenic. That's why I have suggested you to study the geochemical composition of the rocks, and if there is any geological source for this element. And my last question is about the slide 23. You have mentioned that there is not a statistical significant association between arsenic and cancer. Can you specify the type of the cancer for this slide?
Yes, if the total the correlation or the regressions.
Slide 23, Mariano.
23.
Yes.
Oops. Here or here. See here. Here I consider the total cancer, the 6 cancer. In this research, I consider 6 types of cancer originated by arsenic. But for the regressions and propensity, I joined all of type of cancer in a total cancer for simplify the
Okay.
the calculations.
Okay, thank you.
the 6 type of cancer are lung, bladder,
So-
skin melanoma and no melanoma, liver,
Yes.
and kidney.
So in order to simplify your correlation, your calculations and the correlation, you have added all the types of cancer into one index.
Yes, I don't have any correlation with the current data.
Okay. Okay, Mariano,
But
thank you.
in the future, with the other data, maybe I or the better data we have, maybe any correlation, but we need more studies for this.
Okay, thank you very much, Mariano.
Thank you
Welcome.
so much. Anybody has any question? No, no more questions. Okay, let me
Elena,
show you. Oh,
Elena,
yes.
I have only just one additional comment.
Okay, okay.
Not for this research, but I want to emphasize that I think that it's very important to have multidisciplinary teams to have the possibility to take a primary source of data also, not only statistics, to develop teams with physicians and geologists that can work on the file and to be in these towns to evaluate the people and to talk with the doctors, with the in the hospitals, just not only to have a secondary source of data. It's clear my suggestion. It's more difficult. It's an in-deep research, but may provide more information because what Chausen says, it's very difficult to put together the epidemiological data and the geochemical data. So this is a suggestion to develop these kind of teams, to go to there and to talk with the people, to evaluate the people, talk with the doctor, the authorities, and do it to do something stronger. But it's not something bad with your research. It's another idea for the future and to have more information.
Yeah, yes. We have more environmental information for the pathologies. We need the sensors, los sensores, digamos, in new formulas with in the visit and the each patient, a new questions about your habits, labor habits, environmental habits, maybe the constructions, the type of construction, maybe the roof is with asbestos. I don't know, but
Yes, or smokers and no smoke.
yes,
A lot of information.
the nutrition, the habits of nutrition, the position of sun. I'm many possibilities and questions for realize.
And I just second what Diego says. In fact, it's not really a suggestion to Mariano, it's a suggestion to Nelly. I think that for your team, you really need to get medical people on board, get some epidemiologists or really this kind of people working on cancer, to get those people on board in your team. Perhaps that make your indeed make your research stronger.
It's not easy.
It's not easy, but that's all what we want to push.
Arsenic exposure is not a priority in health problems. I'm sorry, we are chemists, but we now with Paulina, we involved one of the authors of the Atlas Cancer, that she's an epidemiologist and she worked on cancer data. How do you say it in English? She is a quantitative methods specialist. So we are working in the Paulina's thesis with her. We got one, and also Mariano have talked with her, and she is involved now in our further research. But I think that that is what we have to do. But the physicians are very far from the problem of arsenic, including toxicologists. So we have to deal with what we have in the multidisciplinary work. Also, statistic work, also to harmonize the data. There are a lot of, how can I say, local problems of the data, because it seems that the data are owned by the authorities of the time, and then they skip the data. We have to search again. It's not so easy. It's not too easy, although we have laws to have public data. But I think that as a first approach, it can have a lot of questions and approaches from your point of view, that they enrich his thesis, because he also was a bit confused with this. But we try to do what is done in other parts of the world, as we saw in our congresses, to see what happens in Uruguay. As all what we have done was to see what happens in Uruguay. But we have also some published works with our own data, with some geochemistry, with the rocks. We begin this with a geologist that died in 2009. She died, she doesn't finish her work. But I think that every contribution that you have done here, it will be very welcome. And of course that Mariano did his very hard part. I do not know nothing about geochemistry. I've learned from you. I know chemistry, and I know what we wanted to have some data. And when he presented this in Uruguay, health authorities, oh, okay, they say they're very good. But I know that we know that this is not an epidemiological study. It's only to know what happens with our available data. For example, the other disease is the diabetes, and also the cardiovascular diseases that we have a high incidence in Uruguay, high incidence. I'm one of the people that have high pressure and problems in cardiovascular. The registries are different and taken into account with different kind of data. If we want to know the diabetes registry, we have to search on the Diabetes Association. It's not an official one. If we want to cardiovascular, we have to go to another issue. So the Cancer Atlas we have a special institution of cancer that deals with the Ministry of Health, that is official and publish this kind of data. But they do not ask about the environmental of what water they are drinking. And also the registry, also another problem that Mariano has is that the registry maybe is in the place that they are going to the doctor and not in the place that they are living. So there's a lot of problems in the registry that we pointed out in this thesis also, with different actors of the problem. He has not defended yet, so all these contributions will be very interesting to his work and to continue defending that. But you know, we do not have any background on this issue, and Fortunately, I have students and people that trust in our proposal, also geologists, senior researchers, and also the geoscience research, how do you say, program that allows me to work on this. Also, they recognize medical geology as a geoscience. They are always complaining about what is geoscience, or what geoscience means. And you are a geoscientist, but you are not a geoscientist, but I am still there since 12 years ago. So that's why Mariana is one of my students in that geoscience program, to show that geoscience can be deal with a chemist. So thank you. I don't know if you Georgian, and you Dimitrios, with your point of view, can be in touch with Mariano for the next, for continue working on this to enrich his knowledge and all the questions that we have to, in the thesis work, he has a lot of difficulties. Also, we presented that in some congresses, the difficulties to work with in these problems, the advances and difficulties. And but I think that we are working on how do you say, we are advancing in this, although local or regional stakeholders are not concerned at all. In last month, they say, oh, Uruguay, the Ministry of Health say that the water agency has 2 years more to lower the data. But they do not have any epidemiological work or the impacts on, for example, on population, on how many population is affected with the official wells that has higher levels than 20. That is the official level. But they are not concerned with those private wells that are also used by people and by towns. And it's very, it's very common to use that water for, also for, how do you say, for putting over the plants and for cattle also. So there's a lot of things that we have to learn from zero, no background studies. That's why they call us for the press to give some notes and information about this. So yes, thank you.
Thank you very much. I want to show you the next webinars. Just let me share something with you. Where is it? This one. The next edition will be on the 9th of December, and we are going to have Paulina that is here today with us, and with the medical geology study of a groundwater arsenic contaminated area in Canelones, Uruguay also. And after Paulina is going to be with us Matthew Okonkwo Ekene from Nigeria, that is going to talk about the health effects of associated with inhalation of airborne selected geogenic material from mining operations. Very interesting. And also I want to show you, let me see, where is it? Here. This is the certificate for Mariano. From the International Medical Geology Association, the Student Award. He was awarded during our MedGeo 2021 conference, the virtual one. So, Dimitrios, we want to emphasize that we think that the students are very important for our association. So we need mentors, we need collaboration, international support, and this is a sample of this kind of vision and mission that we have as an association. So thank you very much, Mariano, for your time, from your research, and for being a part of IMGA.
Thank you a lot for the opportunity. Well, I don't prepare
No.
at this card, but
Thank you.
thank you a lot for this opportunity.
Okay, well,
Well, thank you
thank
so
you,
much,
friends,
everyone.
and we will see us the next week, no? Or the
Yes,
other,
with
yeah.
Paulina.
With
Yeah.
Paulina that is here. Okay, feel free to share the webinar information when I don't know, with your students, fellows, and it's open. It's an open and free activity. So thank you very much.
Okay, thank you,
Thank
Diego.
you.
Thank you very
Bye-bye.
much, Adam.
Bye-bye.
Thank you.
Bye-bye.
Bye-bye.
Bye.
Thank
Bye-bye.
you. Ciao, ciao.
Thank you.
Bye-bye.
Thank you, Chance. Ciao, ciao.